Okay.
All right, so hang on. Let me go back to the properties. And then looking at the supply air temperature. Okay, so where does it say return air in this like little description? Because I didn't. You mentioned the return air.
It doesn't say it anywhere. It's just the way the program is working.
How do you know?
Every degree. Okay.
Oh, the space temperature. Yeah, because we don't have space temperature.
Right. You have return air, and that's the logic it's looking at in the program. It's got
Mm-hmm.
in order for this to be changeable here.
Okay.
For every degree space temperature, or let's change that to return temperature. Okay.
Yes. Yes.
Falls below set point. Your set point is 85.
Yes.
Return temperature 79. That's 6 degrees.
Yeah.
Okay. The reset supply upwards by 3 degrees. So 6 times 3 is 18.
By well, wait. So by
70.
supply upwards by 3 degrees. So for every degree, 6 times 3 is 18.
It's gonna reset it up 3 degrees.
Okay.
Your set point.
So now we start at 53, add 83. Now it's 18 plus 55. That's 70. That's how we get the 73. Correct?
That's correct.
Okay. And then what does it do with that 73? I guess.
Well, so that's at 73. That's going to control your PX station. If this supplier temperature is higher than 73, that's what's controlling your PX station.
Okay.
Okay? So you'll get, like, on an occupied mode, when it's really hot in there, you're going to get some cool, which is fine. I mean, you want it anyway. But you're really not, at 73 degrees supplier temperature, you're not going to use that for humidity.
Yeah, it's not. It's going to not cycle. It's not hardly going to cycle at all. It's going to be just hit 73 and shut off.
So how does it determine
Right.
when to go to stage 2? I guess after that.
It's in the sequencing in the program, which again, we can't see the logic in here.
Okay, let's go to properties. Maybe you know what this means because
You can't see the logic in the properties. It doesn't actually tell you in the logic
what's
when stage 2 is coming on. Well, there it is. Wait a minute. I'm sorry. It does. At 70%.
so
Whenever the output is at 70%, it's going to call for stage 2.
what does HYST stand for?
Hysteresis.
History?
Hysteresis.
Oh, what's that mean?
Which means, how do I explain this?
Something to do with humidity?
No.
Okay. Calculus?
Yeah, it's just another variable in there that it looks at, so that when it says 70%, according to that would actually have to go to 90%. No, I'm sorry, 50%. After cooling stage 1 is enabled, and if the cooling output is greater than 70% with a hysteresis of 20, so you should be able to take 20 off of 70, that would be 50%. So cooling 2 will come on 5 minutes after cooling 1 is enabled, and cooling output is greater than 50% because of that hysteresis. And you can change that hysteresis value, like you can make it 0 and just make it 70%.
Okay.
But you can see stage 3 is at 45.
Yeah. What if we were to do this? Since we don't want to, what if oh, where'd it go? Supply air cooling. What if we make this 4?
Your biggest, you're actually, well, you can change it. You can change it to 4. You can change it to 2.
Once it's a 4, then it'll be higher, and then maybe it won't be turning on right now, right?
Why do you not want it on?
It's just to prove a point. Like if it's below 85, I wouldn't want it to. be on, I guess.
Well, we have a maximum of 80 degrees.
Oh.
So if the return air temperature ever gets above 80, then it's still going to want to come on because we have this maximum at 80. So you'd have to make the maximum higher, like 85 or 90. I mean, you're going to let it get to be 90 degrees in the space?
Oh, no, absolutely not.
No, just... I don't think it's, yeah, obviously 80 is too high.
Well, so the first thing I would do is change your unoccupied cooling set point from that 85 down to something more realistic, like 78.
I thought 85 was realistic. I mean, no one's in the building. Who cares if it's 85, right?
You don't want a wide gradient.
If you let the building, if it could possibly get up to 85, first of all, not only is the temperature rising, but the humidity is rising. So when you're in occupied mode, though, you're back to 72.
Okay.
So now all of a sudden you want to bring that back from 85 to 72. Well, it's not going to happen as fast as you want it to.
All right. Well,
yeah. So you need to do something more logical, like see how they have 72 occupied. I mean, I would do something like 78 or something like that.
Okay, let's do that then.
Unoccupied. No.
Oh, I see. Are you?
You're occupied.
You want 78? Okay, that's fine.
Yeah.
That seems pretty toasty. I think that's too cold, right? Should that be 74?
No, it's not too cold. They never complained, have they?
I'd be cold at 72, but I'm a baby.
Yeah, but here's the thing, okay? You're saying the return air temperature is 72. If the return air temperature is 72, the VAV boxes in there have to be closing in the space. So actually, they're going to be getting less air directly into space.
Right.
So technically, whatever your set points are for in the space, they're going to drive that return temperature more closely than what you're setting right here. Not just looking at the return temperature coming back to the unit.
Wow.
So if somebody still needs cooling, I'd still, not want to shut it off based off of that or reset it off of that.
Okay.
Yeah, the only
much higher.
Okay.
All right, so just leave it at 72.
Yeah, 72 is fine.
Okay. Did we save that? Okay, and then maybe I should do this. I should take the... I should probably put this back to normal, like 5 minutes, right?
Yeah.
I was just doing this so I'd get results faster, but...
And that's fine.
And we changed the reset ratio too, didn't you? From 3 to 4.
Yeah.
I don't know how that'll...
Yeah. So you're not banging all your stages on and off.
What about this? Should we keep this at 3 or what?
Yeah, put it back at 3.
All right, then I'll go to schedules and I'll change. What does this schedule do? I don't even know. Occupied or not occupied, huh?
Yeah.
Just to configure it.
Just change Wednesday for 10,
8 p.m. I guess.
Or 8 p.m.
Yeah, 8's good.
Holy smokes. Okay, so what do we have left to do? Just wire take out the solenoid number 3 and just use 1 and 2 for the compressors, right? This mixed air can be turned off, right?
How would solenoid 3 operate?
Well, what 3, we won't need it now, because what 3 was doing was controlling the third stage to make the compressor go fully loaded, the old compressor. And we don't have that feature anymore.
Yeah, it was just, so that was just controlling an unloader. It wasn't actually controlling a solenoid valve at the coil, right?
Correct, yes. That's all it was doing.
Your solenoid valves at your coils are coming on with your staging of your compressors.
They were. With the new setup, we went to 410A. We don't need that. They told us we're just going straight two expansion valves, feeding all the time. We're just turning the compressors on and off. So that's been eliminated too.
Did you change the coil?
No.
That's still the same coil?
Right. Yeah, we converted it. It seems to work. That's all.
Do you know how many circuits you have?
Oh boy, I couldn't tell you exactly.
So that's going to be off the distributor.
Right. Yeah, the distributor. There's 2 distributors.
How many circuits on each distributor?
Well, it's like one coil has 2 more circuits than the other. They're not equal. One has 6 and one has I think 8.
Where's this coil? You want to show me?
Yeah, they're both here. You can see the.
You have to have a minimum number of circuits per ton for oil return.
Oh, you have the minimum number of circuits for oil return?
Yeah, minimum number of circuits per ton for oil return.
Oh, snap.
So if you're dropping on, if you have the whole coil active, you're dropping off one compressor, you're still feeding all the circuits with refrigerant.
This is what I think is 8.
However, the velocity drops in half through all those circuits then.
Okay, so your
compressors are equal, right? 12.5 ton each.
Yeah, they're both. Yeah, they're the same in the unit. Yeah.
Are all the circuits used with one compressor is activated, Greg?
Correct. Yes. The way it is now, it's one liquid line split between the 2 TXVs.
So one liquid line is splitting into 2 TXVs. So one compressor feeds the whole evaporator, correct, Greg?
Yeah, 1 or 2. The way it is, the way we're doing it now. Is that like a? Can that be a problem?
Yeah, well, I don't know. How many circuits do you have? Did they have 2 solenoid valves in there before, one for each TXV?
The way with the original setup, yes, but we were told by Trane and Fort, don't do that. You don't need to do that. Get rid of the solenoid valves. Don't.
Well, then make sure you have that in writing somewhere. Because if you have a problem with oil return, eventually it's going to kill your compressors, and then somebody's going to come back and say, "Well, you guys."
Yeah, the last 2 compressors failed pretty quickly, Greg.
Yeah, well,
was that
and we're
because
not
of that? Was that because of the piping was not enough oil return?
Nah, we really don't know what killed them. It could have been.
How was the setup before?
It had, like I was showing you, it had the 2. They're laying on. There's the expansion valve. They're somewhere. They're here. There it is. Right there.
When one
compressors die because they locked up or because they burn out or what?
Why did the compressors die? Did they locked up or burn out? Do you know?
There's some kind of mechanical failure. They might have locked. We don't know exactly. When I came in, when this all started last year, the compressors the compressor stator was grounded. On
that's an electrical problem.
Right.
Yep.
It was a grounded stator, but I don't know if it was something broke in the compressor. Because what happened was, the tip-off was it grounded the overload switch that Trane used in their compressor, and was blowing control fuses. Then when I investigated further, then I found the grounded stators. They're shorted to ground. So something broke and caused that. I think.
Controllers have, your compressors have sight glasses in them?
Sight glasses in the
oil, yeah, they do. Yeah, I'm looking at that. We were running them yesterday. This morning one of them looks the oil level without running it. The oil level looks about halfway. The other one, I want to add some oil to it. I haven't done it yet, but it's a little light.
How many circuits do we have on? Yeah.
This one has more. I think this one has 8 tubes, eight on a distributor. The lower one has 6. For some reason, this original, we didn't know this till we pulled the cover off. We thought they were an even split, but in reality is one of the evaporators is larger than the other. It's like 1/3, 2/3, if I were guessing. The lower.
So it's going to be 12.5 divided by 14. So you're going to be roughly at 0.9 tons per circuit.
Yeah, the upper coil has, I think, 2 more circuits. I had to count them.
8 and 6, right?
The lower one, the coil, they're basically 2 separate coils stacked on each other. The lower one, the smaller of the 2, is obvious, you can see it, has 6 circuits. And the upper coil, I think, has 8, but I'm not.
Why don't you count them now?
It's hard to see, but.
Okay, so that's 14 circuits. The full coil.
I believe so, yeah.
14 circuits.
Yeah.
So at your minimum capacity, you're going to be at 12.5 tons. So 12.5 divided by 14 is around 0.9.
5, 6, 7, 8.
So you're at 0.9 tons per circuit.
Okay, is that?
Usually coils are made to operate down to 0.5 or 0.6 tons per circuit. So that's probably why Train told you you're okay.
Wait, so these coils are big enough for our compressors? Is that what you're saying?
Oh, more than big enough. Should be.
Not the coils, the circuits.
The circuits?
Circuits. They're getting enough. You shouldn't be getting enough velocity to get oil return out of the circuits.
Yeah, no, I get what you're saying. Yeah, so you're saying with the 14 circuits we should be okay. Now.
Yeah, you're around 0.9 tons per circuit, which should
okay.
be under normal coil manufacturing standards. That should be okay.
What's the minimum you want for return? 0.5, you said?
Usually, in current today's standards, it's 0.5.
Okay, so we're above 0.5, so that's good.
Now, I got one question. Okay, should we be staging the compressors, or should we, because of the oil return, should we run them together all the time, on or off?
No, stage them.
Still stage them.
That's the point that we were just stating.
Okay.
Yeah, when you're staging the compressors, when only one is on, you'll be at 0.9 tons per circuit.
Right.
It should be enough
okay.
velocity to get oil back through the coil.
Okay. I needed that cleared up because that was a thought of mine. I was just thinking of that. I was a little worried about that.
When both compressors were on, you're at 1.8 tons per circuit.
Okay.
Oh wait, so you're saying if the compressor was too small, it might be a problem for getting the oil return. Is that right?
That is correct.
We wouldn't have enough velocity to push it back through the suction line back to the unit.
Well, what's the formula you use to determine that whether there's enough velocity going through the circuits?
Well, so don't think of it. There's 2 different things you got to talk about here. One is the suction line sizing and whether you need traps or not, but the other one is physically how do you get the oil out of the coil. So it's the number of circuits on the coil that are active at any one time. So in your particular case, you took those 2 solenoid valves out, so you always have 14 circuits active.
So
yes.
The more circuits that are active, the better for return of oil, correct?
No. The more circuits are active that are not necessarily better.
No.
It all depends on what your minimum is on your loading. In your particular case, you have a second compressor, so you're unloading it to 12.5 tons. So you divide 12.5 divided by 14 circuits, and that gets you like 0.9 tons per circuit.
Okay.
Oh, I get it.
Yeah.
Which says you have enough velocity through the coil. And I'm just talking the coil.
Right.
You have enough velocity through the coil to push the oil out of the coil.
So if we had like 50 circuits, that compressor wouldn't have enough velocity to work.
Yeah. Right, you'd have 0.4 tons per circuit.
Yeah.
Yeah, okay.
And a lot of times people don't pay attention to that, and that's why they kill their compressors. But you don't get the oil coming out of the coil. Has nothing to do with the suction line.
So it could.
Suction line's a whole different story. You still have to worry about your suction line, whether it has enough velocity at minimal load to push the oil up.
All right, how do we know if the suction line has enough velocity for the oil?
Well, we ran the size that they said the size was okay. We got 2 1/8 suction. And it's probably let's say 60 feet, 70 feet.
Oh snap!
You lose them?
Oh no, you still there, Nate?
Uh-oh.
Sean, on my other number. Can you hear me okay?
You there?
Okay. Okay, great. So are we? So how do we know that there's enough? We are saying the suction line is big enough because, Greg, it's how big? 2 inches and what else?
It's 2 1/8. We ran all this stuff, what we had. You know what? But they made us change the liquid line from 7/8 to 3/4. I had to run a new liquid line from the unit. And that's the size they said to use. I don't know if that has any bearing on anything. And we told them, well, the existing suction line is 2 1/8, and they said that's okay too. But we did change one thing. There was a double header, a riser from the about 5 feet up to where the pipe goes horizontal. The original pipe fitters made like a double riser. It's hard to explain it, but they said no, don't do that. Just come out of the unit. There's a small trap and then we went with the 5-foot riser, but they said keep the pipe size the same. Don't make any changes or double risers, just the same. Or I think it even said that in the piping manual that came with the unit.
Same size out of each circuit, right?
What? Speak louder. Say that again, Nate. Shit phone. We were saying that the 2 inches and 1/8. 2 circuit. Yeah. Yeah. What was your other question, Greg?
Oh no! I didn't have a question. I'm just saying what we
done.
The way it's piped now. Is what we did. The way we did it.
What size is your suction line? What size is the suction line coming out of each circuit?
Well, the original setup was it's all 2 1/8, but they joined the 2 1/8 suction lines from the coils together, and it returns that the one common pipe, and it's been this way since 1987, was one single 2 1/8 pipe home ran back to the unit. There's just a short, about a 5-foot riser from this thing sitting on the floor in the mechanical room, the air handler. Coils are blowing through the coils is horizontal, airflow, and it comes off one side, and then it goes. Like I said, there's a vertical. They teed it. The way they did it, they teed the 2 suction lines together, and then the short piece of pipe, and then like a little. They made it out of 45s, a small trap, and then they went. Then there's a vertical riser about 5 feet. Then it goes horizontal again to the outside.
Okay. But you said it comes out of each half of the coil at 2 1/8, right?
Right.
And you're maintaining that size all the way through. Okay, that should be okay then.
Yeah.
If the train says it, I would agree.
Yeah, they didn't. Yeah, we went around and around with them. Me and the other technician that was out here, and before we started doing anything, that we got those little details cleared up, and then they asked us about the liquid line, which said, well, the old R20, when it was R22, it was 7/8. They said no, You got to change that size to 3/4.
That's to be bigger then, huh?
Or less, smaller. 7/8 is larger, so we had to drop it down to 3/4.
Oh, smaller. Okay.
Yeah, they want a less. Yeah, smaller liquid line.
Yeah, you're right. My fractions.
And that's kind of the way it is. It goes out.
All right. So should we rewrite this program, or can it ride the way it is?
No, you can ride with it the way it is.
Okay. So we just
And if you have to, you can change the reset temperature schedule a little bit. Play with that a little bit if you're having problems or whatever. But
can you show us that on the computer, the reset temperature?
that was in properties,
Yeah, in properties,
supply air,
supply air.
control,
Oh, okay.
down here. You can change this, like the maximum you can change. This is 3, it can be 2, it can be 4, it can be whatever you want. I would still leave this at 55, the base supply air temperature.
Leave it at 55. You're saying, okay.
Instead of 60, yeah, because that'll do a much better job at dehumidifying.
Okay, better job as humidifying. And keep the maximum to 80. You think?
Well, for right now, keep it at 80, yeah.
Okay. Cool, Greg. I think all we have to do is take out the solenoid we're not using and wire in 1 and 2, right?
Yeah, that's no problem. I can flip the wire to 3, the coil on 3. I can eliminate that. But it's really doing nothing anyway because the wire's capped outside. So it's really not a factor either way.
Yeah, because you don't have another unloader to work with.
Yeah, I know which wire came back from the third one. And I can just either leave that capped outside, or I can flip the wire so it doesn't light up. If we don't need it anymore, I can just flip the coil wire and cap it. Yeah, I could deal with that either way. So the way we're set up now, when this thing is running and humming along and it drops the temperature down, it should cycle the compressors on and off. Correct?
Correct.
Okay, that's what I need to know. So we just got to basically get it connected up and humming along and watch it and make sure it's doing what it's supposed to do, right?
But like right now, if we go back to this, you can see it's currently the set point is 55 because you're so far, off the set point.
Right. So we're.
And it's in the cooling mode.
Yeah.
So it's going to try to maintain 55-degree air, and that's what's going to cycle off your cooler.
So it'll stay at 55 until we get a lot closer in the return air temperature to the set point, right?
That is correct.
That's okay. So let's say when it's within a degree, it might drop out a compressor or something, just for example. Drop out a stage.
Yeah.
Okay.
Well, it'll start changing your set point too.
Oh, okay.
Resetting your set point. Yeah.
Right, the discharge air set point.
That's correct.
Okay, so it might raise it up, say from 55 to 58 or whatever, just whatever it wants.
That's correct.
Okay. What's the mix? Yeah. What about the mix thing? That seems to have a set point too. Does that do anything?
That probably was for the economizer.
For the economizer, okay.
Yeah, and that's basically not functional, so I don't think it'll affect anything, right? The fact that it doesn't work.
Right.
Okay.
All right, cool. I have your number on speed dial.
Okay. Well,
Thanks.
I think you got enough to get you going now.
All right. Yeah. Thanks, Steve. You're the man.
Thanks for all your help.
We're gonna explain this to the customer and act like we knew it all the time.
There you go.
All right.
Have fun.
All right. Thanks, man. Talk to you. Bye.